Welcome to HECTV's live interactive program that's part of St. Louis.
The whole production is pulled together.
It's going to be a steel bridge.
The way the cockpit is designed.
The highest rated green building in the world.
Welcome to HECTV Live.
Hi everybody, I'm Tim Gore and I'm very happy to welcome you right now to the Little Creek Nature Area where you're going to have a chance to interact with students from McClure High School and McClure North High School who get to participate in this unique and exciting outdoor education area which is part of the Ferguson-Florissant School District. Today we're going to talk about watersheds and water quality and how we test for water quality. There are three specific ways that you test for water quality and today you're going to get some students who are going to show you in a lab environment how that happens. As always, HECTV Live is interactive. If you're joining us via television or the web, then you can send us your email questions to live@hectv.org. That's live@hectv.org. We're also being joined by two interactive video conference schools throughout the program today, and we're going to have the chance for them to interact as well. But before we go to those students for interaction, we want to give you a chance to see a little bit of the Little Creek Outdoor Education Center. This comes to us from students at McClure North High School, their broadcast journalism class, who put this video together for us.
Little Creek Nature Area is a 97-acre outdoor educational facility owned and operated by the Ferguson-Florissant School District and located in North St. Louis County near I-270. Little Creek is largely wooded and preserved as natural areas with trails, ponds, and several tributary streams that drain into the Moline Creek watershed. Since 1974, teachers have provided ecology, AP Environmental Science, field biology, and living history programs for district students from pre-K through 12th grade. Hands-on, inquiry-based activities provide students with experiences which not only enhance achievement, but cultivate a lifelong interest in the natural world and meet cross-curricular objectives not easily accomplished in a traditional classroom setting. Students also participate in the stewardship work required to meet the challenges of maintaining a nature area in an urban setting. In the 30 years it has been in operation, Little Creek Nature Area has adapted to the changing needs of the district and community.
And now we're in the Little Creek Nature Area Education classroom right here in the Ferguson-Florissant School District, and it's in this area that everybody's going to have the chance to see the exciting activity that's going to occur today as we test for water quality. I want to introduce our guest here with us. To my far right, Eric Hadley, who teaches in the Ferguson-Florissant School District. Eric, thanks very much for being here.
Thank you.
Give the audience a little bit of information about what you do, because obviously an outdoor education center might seem kind of rare for a school district to have.
Absolutely. So I am a coordinator of science in Little Creek Nature Area. So this is my second year in working with Little Creek, where we bring students out here from pre-kindergarten all the way through 7th grade to work with nature. It's like an outdoor classroom is what we have here, and it's very rare. We're one of 3 in the nation that has this opportunity. We also have a 12th grade class that brings students from 3 different high schools in the Ferguson-Florissant School District, and another outdoor classroom experience for them where they're here every day. And we get to do things like we're doing today, along with other kinds of activities with gardening and studying the watershed here at Little Creek.
Thanks so much, and we're really glad to let the world get an idea of what happens here. To my immediate right is Jamila Harris, who's from the Missouri Department of Conservation. Thanks so much for being here.
Thanks for inviting me.
What is it you get to do every day at the Missouri Department of Conservation?
I am a conservation education consultant, and so I do teacher workshop, outdoor classroom development, a lot of grant work with the department, coordinate special events like Eagle Days and things like that.
Well, and you're going to have a chance to interact with our students today as they do their water quality testing.
Yes.
Thanks for being here. And to my left, Perry Eckert, also from the Missouri Department of Conservation, but you're an urban forester, right, Perry?
I am now, yep.
And so, kind of seems like a little oxymoronic term, urban forester. What is it you get to do?
Basically, we help local communities work with their tree programs, try to get them either up and running or improve them from where they're at now. And basically, a place like this, we give them advice on how to manage the forest here.
Wonderful. So Eric and Jamila and Perry, I'll let you guys move out and head that way a little bit because I want to bring in Caitlin because we're going to talk a little bit about what a watershed is and that kind of thing. So just shift over to your left as we do a little on-air directing in the case maybe. And I'm going to, Caitlin, thanks for being with us. Junior, senior, a senior at McClure North,
Yes.
Which makes you a star.
Yes, I am.
That's right, they're McClure North Stars. So you're going to share some information with the audience about what a watershed is. Define it for us.
Basically, all that a watershed is that when it rains, we get a collection of water, and at Little Creek, our watershed is made up of our stream and our pond, and then that all flows eventually into the greater St. Louis area watershed, which is made up of the Mississippi River.
And so if we look at this example here, because we've got a model here of a watershed, what I'm looking at is obviously an example of that. So if you spray it,
all it does is the water begins at the highest location and then it goes down and flows into the greater watershed.
and you can actually see it flowing down and seeing that. So we've got a watershed here, and obviously what happens upstream affects everything downstream.
Absolutely.
And so what we're going to look at today with the macroinvertebrates we're going to find, and then eventually when we test for other elements of the water quality, what we've got here is going to be determined not just by what exists here, but what also existed upstream, so to speak.
Yes, all of it is interconnected and relates to each other.
And that's an important point for everybody to remember. Thanks, Caitlin.
Thank you.
Oh, I'll be seeing you again throughout the program. So Caitlin's giving you some information just in general about a watershed, and obviously you saw the video of the Little Creek Nature Area. Next we're going to meet Justin, because we're going to start to talk about the different ways we can test for water quality. So I'll invite Justin to come on over. And Justin, one way we can test for water quality is just to do it visually, correct?
Yes.
Now what does that mean exactly?
A visual, one way to determine a visual's water quality is by a visual survey. A visual survey is basically a study of the surrounding of a creek. And a good quality creek has vegetation to help the soil so it won't wash up into the creek.
So for example, like if we were looking at the Little Creek video that we just saw, we want to see vegetation right around the creek. We want to see vegetation around the pond, right?
Yes.
We don't want to see just like a lot of soil that's potentially going to erode down into the water creek.
Right.
Very good. Thanks so much. I'm looking forward to interacting with you throughout the program. So there you have one way we can obviously test for water quality is just to look at it visually. Ideally speaking, if you've got lots of good healthy vegetation around your pond or creek, then I guess that means that the pond or creek is also going to be good and healthy. And that's what you're seeing as you look at this B-roll here. You're seeing some video that Ferguson-Florissant students did from the McClure North Broadcast Journalism Program under the direction of Kevin Hampton. And some of the students that you're actually and some of your students that are actually in the video are the folks you're going to be interacting with today, because there you see Caitlin and other good folks. We've talked about water quality testing one way visually, but a second way you can test for water quality is by determining what kind of macroinvertebrates live in the water. So to talk a little bit about that, we're going to bring Mark over. Hey Mark, how are you doing?
How are you?
So macroinvertebrate tests, what does that mean? What is a macroinvertebrate and what are we looking for?
A macroinvertebrate is basically just a small little organism that's actually no backbone for it. So it has no backbone whatsoever. It's actually small enough to where you can see it without a microscope too.
Okay, and I assume certain macroinvertebrates live in different kinds of water, right? So then, but with the macroinvertebrates we're going to find today, they're going to tell us something about the health of the water that we're dealing with right here?
Yes, sir.
So there's certain ones we want to find and certain ones we don't want to find?
Well, it's not that much of a factor. It's what we see in clean water and what we see in polluted water.
Okay. Well, I look forward to learning more about that. Thanks very much.
Thank you.
So macroinvertebrate tests is obviously something we're going to do, and you're seeing right there on that B-roll a sheet of information that students use to be able to identify. There's Mr. Hadley and the students actually getting samples of water that they're going to look through to see what macroinvertebrates live in there. And this video was taken about a week and a half, 2 weeks ago. So the macroinvertebrates we're going to be dealing with today will actually be different ones. New fishing was done so that we could find new and healthy macroinvertebrates. Ideally speaking, they're still going to be swimming around in their water today and living happily with us today as we look for them. So a macroinvertebrate test, a visual quality test, and third, last but not least, chemical tests are also done. So I'll invite Ash over because the second part of our lab activity today is going to be dealing with chemical tests. Ash, thanks for joining us. So what do we mean about chemical tests or whatever when we look for water quality?
Chemical analysis is the last test that we do for looking for water quality. And here we have a water test. So there are like several different water tests we could do. Dissolved oxygen, nitrate test, phosphate test, water temperature, turbidity, etc.
So this sample here, and you guys are going to have a chance to see this up close and personal when we do the water quality test. This sample here is actually includes the little pills or whatever we're going to put in the water. And then if life is good, water turns a certain color for us, right?
Yes, sir.
Very good. Looking forward to doing that, Ash. And so there you see an example of that right now, pH levels, and we're going to be looking at those kinds of images and those kinds of colors when we look later on in the program to determine the kind of water that we've got as a result of those chemical tests. I want to start at St. Elizabeth Middle School in St. Elizabeth, Missouri. St. Elizabeth, come in and say good morning to everybody. Do you have a question right now?
How often do you collect macroinvertebrates and do water quality tests at Little Creek?
Oh, very good. So Eric, the question is, how often do you do this kind of thing and do this kind of testing?
Ideally, we would do the test once in the winter, when the debris is not as dense, and then also once in the spring or summertime. And we try to do that since we have 2 semesters. We do try to work that in twice a year.
So Eric, let's begin the macroinvertebrate test. Take us through what's going to happen here. What are we about to do?
Okay, so the students a couple of weeks ago went down and began learning about how to collect macroinvertebrates. There's several ways to collect macroinvertebrates. We can, at this creek, you saw us using dip nets, and that seems to be the best way to find those macroinvertebrates at our creek. It has a pretty rocky ground. You can also use this device where you would collect the macroinvertebrates from the bottom, and that gives you a really definitive area of finding those macroinvertebrates. We also, at the pond then, since we're going to look at our creek macroinvertebrates and what we found at the pond, then we'll use a dip net like this, a little bit longer, and also the ones that you saw in the video before. So what we're looking for are macroinvertebrates that are in our water. It helps indicate the health of our watershed. It helps indicate the health of our creek and our pond, which also helps us understand how healthy our water is. So at each table we have the creek and the creek over here. And then we also have a pond. Justin's going to take care of us at the pond. There's still two containers. And we'll see, okay, are there some macroinvertebrates that are found in healthy water? There are some macroinvertebrates that are found in healthy water that have to live in pristine waters because their gills will get covered with sediment and they can't handle that. There are some that are found in fair water. They can handle a little bit of pollution. And there are others that are found in pretty polluted waters, and you would not find any of the healthy organisms in that water. So we're just going to see how healthy our creek and our pond is today.
Well, great. And the students are seeing now, and the world is seeing now your water as you look at it. So students, I guess the process is we just begin to look through them. So put on your goggles as needed if you don't want polluted water splashing into your eyes or whatever the case may be. And tell us and as you guys identify things or see things, feel free to call our attention to it, because we're also going to be looking at things on your Petri dish under the microscope as well. So let's begin that process. And as they begin to look for things, students, we're going to come to you to help us identify what some of those examples are, as well as finding out other questions that you guys have. And don't forget, if you're watching us from the rest of the world, not one of our interactive classes on the web or TV, email us your questions to live@hectv.org. Now, Jamila, as the students begin to work here and they start looking at macroinvertebrates, is this something that you would do regularly? Is this part of what you do regularly in your position when you work with student groups?
Yes, we have a Discover Nature Schools program where we do, with our middle schools, we do water quality testing and macroinvertebrate sampling as part of their field trip. So we go out and we identify, and it's a chance for the students to become the scientists, do those investigations on their own.
Very good. Now I want to direct us right here to the table that Caitlin and Diamond at, that ideally speaking we can also switch to Pete's camera, our handheld camera, so you can see. And obviously we've got a nice little sample of something right here that Caitlin's pulled out of the water, and very impressively pulled out of the water, Caitlin. Obviously you're not worried about your hands there. But you're now you're going to use this sheet that we've gotten in advance. You're going to, in essence, try to compare what you're seeing in the Petri dish to what the sheet shows, right?
Absolutely. So this is a crawfish, and it lives in the group 2 taxa, which means that it can live in somewhat polluted waters, but it can't survive in polluted water. So this is an isolated indication that we have a good water quality, but we need to put all 3 tests together to find out what we really have.
So this is a crawfish.
Yes.
And people may be familiar with that in a lot of ways. Crawfish is something that in this area of the world, and obviously as you go down south, you see quite a few of, actually.
Absolutely, yes.
Oh, very good. So is this kind of like, you've been out here before, is this kind of unusual, or is this kind of like, do you see this kind of thing this size? Is he a biggie?
He's very big. We usually see a lot of baby crawfish that are very easy to catch, but this is a very interesting find right here.
Okay, very cool. And as you guys can see, he's going to crawl right on out. And Mr. Crawfish Man, would you like to talk to us live? Evidently, he's a little bit camera shy today. Caitlin, thanks very much. We're going to move over here to where Ash and Mark are diligently working. Oh, and we have a different creepy crawly that's appearing in your Petri dish. And I see we've got some really tiny thing roaming around in here, as well as the bigger item. So let's look at the bigger guy first. And if we look at the bigger guy that we've got there, and students that are joining us interactively, feel free to begin to look at your sheets as well. Who do you think this is, guys? What are we looking at here?
Well, we're looking that up right now. And the sooner we find out, the better we can identify
Well,
them.
all right, fine. I'll let you guys do that process as we look at it. You guys can see it's happening. They're checking some things out, and they're noticing perhaps.
It is a caddisfly or possibly a stonefly.
And I noticed that it says it's Group 1 taxa. So when we talk about that, because Caitlin had mentioned with the crawfish there was a Group 2 taxa. When we look at this Group 1 taxa, is that an organism that likes really healthy, clean water, or what?
That's right. It's for better quality water. And the better the quality, the more
So if it was poorer quality water, we might not likely find him here.
Probably not.
Okay, very cool. All right, gentlemen, I'll let you keep doing your work. And what they're doing, obviously, as we go through this process, is they're recording their data. They're going to be recording their data. We're going to see what kinds of information they find. But I want to move now to our third table back here to find out what's going on back here in the wonderful world of Justin. Because you've got, sometimes life just works really well for live television, and the creatures are really good and agree with us, and we get different ones at every table. Okay, Justin, what are we looking at here?
A dragonfly nymph.
A dragonfly nymph?
And a damselfly.
Now, is it possible for us to take your dragonfly nymph and the dazzlefly nymph and let's take them over to the microscope and look up close and personal?
Yeah, sure.
And so, as we move to this location where we're going to look under the Petri dish, and you can actually put it there so we're able to see. And Eric, take us through how are we going to organize this so he's able to see, and then we can...
Underneath here?
Yes, and we can see everything properly. Okay, Eric will take us and put it right there, and then we're going to zoom in. Okay, so we are currently not able to see that guy through the microscope, so I will bring him back up here and let you guys work on focusing the microscope so they can see it. And as you guys do that, and we can work on that off camera, let's go to some questions our student groups might have. I want to go back to St. Elizabeth again. St. Elizabeth, a question for any of the creatures we found so far or for any of the students? What's a question you guys have, St. Elizabeth, about these macroinvertebrates?
Have you ever found like a water penny larva?
We have not found one at Little Creek in my 2 years here. I don't know if before there were, but we have not found any water pennies.
And just so, I believe we have a slide image of a water penny that we can bring up as I talk to our technical staff in back so the world can see a picture of a water penny that the students are asking about. But St. Elizabeth, I'll ask you a question as we look for that. Is there a reason why you ask about a water penny specifically? What about a water penny made you intrigued to ask that question?
It would be cool to see.
Okay, very cool. We've gotten an email question coming to us from Montana, wanting to know if the invertebrates that you guys harvest die, or do you get them, or do you return them to the creek?
That's a very good question. Typically, we stay at the creek, so we return them to the creek right away. And as you can see, the students are making sure that they stay in water, even when they pull them out on the Petri plate. And that's real important because they have gills. So if they're not in water, they're holding their breath like we are if we're in the water. So after we're through here today, we will take them back down to the creek where we found them, or to the pond, and where we will return them.
And Eric, as we look at this guy close up, and obviously we've got a little bit of a shadow just from the microscope itself. Again, what kind of creature is this?
This is a dragonfly nymph. So this will eventually turn into the adult dragonflies that many of us are familiar with.
Right, and when we look at the dragonfly up close and personal, and this would be true of, I'll ask, is this true of not necessarily all macroinvertebrates, but this kind? They have different body parts, right? They've got a thorax, etc. What are we looking at here?
So we're looking at the, oh, that's a good picture there. You can see the abdomen, the thorax there in the middle, and then the head.
So let's just take, you know, we're gonna risk a little bit of water, Caitlin and Dime, while we walk over to the microscope here. The joy of live television. Hopefully I will not trip over with the creatures. We'll bring it here. And I'll have you guys just join me right over here then as we begin to look and talk about this. And Caitlin or Dime, whichever of you wishes to speak, what do you think we've got here?
These are 3 damselflies of various sizes.
3 damselflies of various sizes. And is a damselfly, I don't want to say it's a good thing, bad thing. Is it similar to the crawfish in terms of the kind of water it likes to live in?
It is. It's also in the group 2 taxa. It doesn't have a huge indication of what our water is, but we know that they don't live in polluted water, so that's a good thing.
Okay, very good. And you guys are still recording data, right, Diamond?
Yes.
All right, I'll let Diamond and Caitlin still record a little bit of data. I want to go back to our student groups as I move around, and I'm going to go back up here to Mark and Ash again. St. Elizabeth, do you guys have another question right now? If so, come right on in and ask it.
Sure. What's the largest macroinvertebrate that you've ever found?
Oh, okay. The largest macroinvertebrate that you might have ever found. Jamila, as we think just in general terms about macroinvertebrates, are there certain macroinvertebrates, Jamila or Perry, whoever wants to answer it, that are automatically larger? Come right on up.
I think your crawdads are probably going to be the biggest ones we're going to find in
I think probably
Star Creek.
And that's a nice size crawdad. I'm not quite sure I would necessarily be cooking him yet and eating him as we might down south in some jambalaya, but he's looking pretty good. You're going to notice, I want to, if we can, see this image of what the students are doing right here as they draw. Ash, talk to us a little bit about what you're doing as you identify, and why is this part of what the work is you're doing?
I'm identifying the animals that we find in here. So I got caddisfly, which is from group 1 taxa, and from group 2 taxa I found damselfly.
And so you found them so far, and actually you're putting into your notes, so to speak, you're drawing them yourselves to remind yourself what they look like.
Yes, sir.
And from a scientific perspective, why is this kind of thing important? Why would a scientist, why would a lab technician want to record it this way as well?
So that we know the water quality, if it's good, it's in group 1 taxa. If it's fair, it's group 2. So.
Very good. I'll let you guys keep working. We're going to move all the way back here to Justin again. Justin, we found, oh, Justin, shall we move to the microscope? I'll let you carry, because Justin's found a really interesting creature for us. And before the rest of the world, we'll let the rest of the world have a chance to look at it so we can identify it a little bit. I'm going to go to Hinckley, Minnesota. We're going to put it right under here. We'll raise the microscope up a little bit as we need to. And I'll ask us to go to our microscope camera, and we can begin to focus as we need to. Bringing back a little bit more. Hinckley, Minnesota, I'm going to go up to you guys. Do you want to take a stab? What kind of creature do you think we're looking at here as you see this happy little guy in this cup?
A leech.
Okay, you think maybe he's a leech. Okay, Brandon, that's an interesting idea. St. Elizabeth Middle School. St. Elizabeth, who do you think this guy might be? I'm hearing tadpole. What do we have here, Justin?
A tadpole.
A tadpole. A tadpole is going to become a what eventually, St. Elizabeth? Yes, if life is good, a tadpole is going to become a frog. So, Justin, what does this tell us potentially about the water? Is it really good that we've got tadpoles roaming around?
It really doesn't.
Okay.
Because they can tolerate many different kinds of pollution.
So a tadpole could exist in good quality or even very poor quality water.
Yes.
Okay, very good. Thanks very much. I'll let you take him back because I know he's continuing to do some stuff there. And the students are just continuing to record all sorts of data. Hinckley, do you guys have a question right now? I'll go to you guys for a question.
Do you ever have to dive in the water to get them?
Our creek isn't very deep, so we don't have to do any diving in the creek, and so that's how we do it.
Right. You're getting everything through those big nets that we're seeing. Go ahead and raise that up again, Eric, so the world didn't see the big net. That'll be good to do. So the students continue to record data. We're going to get lots of information from them, and as they do so, we're going to attempt to go back to the creek again and find out if our folks are down there for Skype, just so Brianna can come in and say hello from that location. Hi, Brianna.
Hi, everyone. I'm here live at Little Creek with a student named Evan from Florida. He participates at the Little Creek School. Yeah, so we're going to check the turbidity of the water here. So, Evan, what is it that you do to check the turbidity of water?
Well, whenever we check the turbidity of the water, we check to see how much sediment's in the water. And that affects the way that the animals live and just the cleanliness of the water in general. So I'll get started here, and what we'll do is we'll fill up this bucket. Try to fill it up more.
Go right ahead and keep going with that.
Should be fine. And now we will take this card here, and we'll just check to see how foggy and dirty the water is in comparison. So you see that it's darker than this right here, but it's a little bit lighter than that. So come over here to our quality guide, and I will say, that's probably around it's probably 10 to 20 JTU, which is pretty good. It's better than most water. So since now we know that it's at 20 JTU and it's good quality of water, we know that there's a good amount of animals. We have a good amount of fish in here. We have good macroinvertebrates and stuff like that, which overall means that we have pretty healthy water. And it means that we don't have sediment in the water, which can get in the animals' gills and lungs. And so.
Well, thank you, Evan. Now let's kick it back to Tim.
Evan and Brianna, thanks so very much. We're glad you could come and join us from there, and thanks to everybody at Ferguson-Florissant, McClure North specifically, for making that Skype connection available. What Evan was demonstrating to you was one of the examples of the chemical testing that we talked about at the beginning of the show as he looked at water quality. That was turbidity, that was the clearness of the water. We're going to return to that again later on in the program in a little bit, but I think it was a good moment to do that because we'd just seen a variety of creatures. So you get an idea about the level of clearness of water and the clearness of the water quality that's there, and this of course is where these samples came from. Now Ash, you guys have raised your hand because we've got a nice big guy here, don't we?
Yes, sir.
What do we got?
It's a crayfish.
It's a crayfish indeed, and he's pretty well developed, I would say, gentlemen. Exactly right. And so as we look at him closely, I want to go back to our student groups again. St. Elizabeth, a question from you guys?
What does JTU stand for?
Oh, what does JTU stand for? As he was talking about a turbidity level, Eric, and those kinds of things, or Jamila, whoever wants to speak to that. Jamila, go right ahead.
JTU stands for Jackson Turbidity Units. It's just the unit of measurement, and it's how
long of a water column it would take to obscure a candle flame.
Yes.
Okay, of course, and that's something that we do on a regular basis.
Exactly.
Excellent. But that's a really good specific question, St. Elizabeth. Thanks for noticing that because that helps everybody understand exactly what we're looking at. Hinckley, Minnesota, another question from you.
When is the best time or season to collect the macroinvertebrates?
Is there a certain time of day and or evening and or season that's really best?
I think spring's usually one of the better times. As we get further into the summer, things aren't reproducing as much, so we don't see as many things in the water. So generally, I think, at least under the stream team protocol, they like you to do things in the spring mostly.
Very good. Thanks for those questions, Hinckley. Don't forget, you can email us your questions to live@hectv.org. That's live@hectv.org. We've gotten some. We're going to begin a shift now from the macroinvertebrate test to the water quality test as the students put their creatures back in the water. Eric, any kind of summary information you'd like everybody to know about this kind of test before we move to talk about other examples of water quality testing?
Well, we could real quick talk about what was the general type of organism that we found in the creek water between these two. Did you find more of the type 1, type 2, type 3?
So Mark, what did you guys find? More type 1 or type 2 taxa as you look back at your results?
We definitely found more type 1.
Okay, so we've got more type 1 over here at this creek table. And Caitlin, you and Diamond?
We ended up with mostly type 2.
They ended up with mostly type 2. That's kind of interesting. And what did you find back over here, Justin, with the pond?
Type 2.
Type 2. And type 2, if I'm remembering correctly, Eric, is fair quality water?
Fair quality water.
Okay, so we've got a fair quality water. And does that surprise you?
No, that's about what I thought it would probably be. Also based on the past years of doing it, there has been some restoration at the creek that I know Perry's very familiar with that has actually helped improve the quality of the creek's water. So that's about where I thought it'd probably be.
And obviously, so the world knows, this is a very small sample size we're dealing with here. So do a little bit of extrapolation for us. I mean, to really get a good sense, you've got to test over days, over a period of time, over a large amount of the water, or what?
You'd want to do at least 3 different locations in the creek so you know that it's not just this place, maybe there is something going on at that location, so you do want to spread it out over specific three areas of the creek.
Very good. I'm going to let our students finalize everything they've got going with their macroinvertebrates so they can clear up their space a little bit, go to student questions, and then we're going to be ready to talk about water quality testing. Hinckley, do you guys have another question or comment you want to bring up?
What's the smallest bug you've ever recorded?
Oh, the smallest kind of little creature. Eric, what do you remember? Or student? We had some really tiny things today. What's the smallest? Justin, did you find anything that's really tiny?
Oh, a
Dazzlefly.
A dazzlefly is pretty darn tiny. Mark, did you guys find anything really tiny today?
The smallest that we've ever had so far is a scud.
A scud, and a scud is a what?
It is a little small macroinvertebrate, and it is relatively, well, small.
And we've got an image we can bring up of a scud so you guys can see it up close and personal. And there you can see exactly what a scud looks like. Obviously the size is a little difficult to figure out based on what you're looking, but he's a little teeny creature, smaller than a snail basically. That's good. Okay, very good. So thanks for all of those questions. And we're now going to move away from macroinvertebrate testing to get to water quality testing. And you guys may remember from the first part of the program, we described what water quality testing was for and why it mattered so much. And there's different ways, different things that we're testing for. We're testing for dissolved oxygen, we're testing for phosphate, we're testing for nitrate, we're testing for pH, and we're testing for turbidity, which obviously Evan and Brianna already did for us. So remember that turbidity information they already gave us. That was a fairly clear looking creek down there that they were getting to. Think about that as we move to the rest of our water quality tests. And don't forget, you can email us your questions to live@hectv.org, which is a good time for me to open up my iPad here and see what email questions to get to that we have not been able to get to so far. Oh, is the creek or pond natural or was it built here? Eric, is this a natural environment?
The creek is natural. And it is spring-fed, and the pond was man-made about 2.5 years ago.
Oh, very good. Thanks for that question. And Jamila, you or Perry might want to answer that. We've got an email question asking about fertilizers and the drain-off effect of water quality on both macroinvertebrate life, non-source pollution, whether it's fertilizers or whatever. A very important topic, right? How do you guys monitor that kind of thing with the Missouri Department of Conservation?
Well, actually, we use stream team data just to monitor the overall health of the stream over a period of time. And if we see that health is declining, then you look up in the watershed and determine maybe what's going on. And it could be that there's a whole bunch of new fertilizer inputs into the watershed or something like that. And that's how this kind of ties in with what's going on with the watershed.
Great. We're going to go to our water quality testing now, and we're going to test for a variety of different things. And I'm going to start here with Caitlin and Diamond because they're going to be testing for dissolved oxygen to start out with. As she pulls out the nitrate thing instead. Oh, Mr. Gore, you confused me. So dissolved oxygen, why do we care?
Dissolved oxygen is just oxygen molecules that have been incorporated into the water by byproduct of photosynthesis and aquatic plants and turbulence in the water. And the animals just need to breathe, plain and simple.
Okay, so take us through the test. What are we going to do here?
All right.
We're going to, obviously, we've got water sample already in this nice little #1 container.
This water sample is
is
from the creek.
So this water sample came from the creek. Remember that, guys, because we're going to do a comparison between both creek and pond water. So this is from the creek. So you get water into the tube.
All we do is put water into the tube, put 2 tablets in, screw on the cap, and invert it for 4 minutes until the tablets have dissolved, and then we wait 5 minutes for our color to develop, and that color will tell us how much dissolved oxygen we have in our water.
Very good. So we're going to let that happen. You guys are going to notice that dissolves and happens, and we're going to come back for dissolved oxygen test results, obviously in a little bit, but that takes a bit of time, as Caitlin just mentioned. So we're going to move off of dissolved oxygen, and we're going to go to the wonderful world of pH. So I'm going to move myself here, and gentlemen, Mark or Ashley wants to talk about pH and why we care about it. Ash, go for it.
All right. pH is like the water acidic level or basic level.
Okay.
You don't want to drink acidic water because it kills you. So it's the same thing for the animals. So we test pH levels. So
the less acidic, the better.
Yes.
More base, better.
It should be neutral.
It should be neutral.
Yes, 7 is the neutral, what we drink.
And so what's the process that we're going to do for the test here? You're going to take water sample again, and you guys are going from the creek also, right?
Yes.
All right, so take us through it, Ash. Go ahead and put the water into the tube and take us what's going to happen.
So we're going to take 10 ml of water into this tube. And then we have tablets, pH level tablets here. We take 1 tablet and Mark. So we put a tablet in there and we have to wait for 5 minutes.
Right, so you're going to wait a little bit of time for this too. And ideally speaking, the pH is going to come out pretty neutral in quality. We're going to end up with something. If life is good, what kind of color do I want here, Ash?
green.
Green. I want something green. Okay, remember that, everybody. If life is good, I want something green. If I'm getting something black, I think we might be in trouble. Okay, so and hopefully that's not happening, Eric, as we look here at the water quality. We all hope for that. We've already done the turbidity test that Evan and Brianna performed for us, so don't forget that example. But we also want to give you guys a chance to look at what's called a phosphate test. And that brings me back here to Justin. And talk about phosphate. Why do we care about phosphate? Why does this matter to us?
Well, phosphate occurs naturally in rivers and streams, and phosphates helps plant life grow. Without too much phosphates can lead to algae growth that depletes resources like dissolved oxygen and water.
So we want a good level of phosphate, but not too much.
Yes.
Very good. And so take us through the process. You're going to get your sample as well?
Yes.
So Justin opens up his test tube and gets his sample. And am I remembering right? Phosphate is something that you find in a lot of like lawn fertilizers, garden fertilizers. You're going to find phosphate in there as well. And so over-fertilization can get you too much phosphate in your lawn, and that could obviously affect water quality throughout the rest of the watershed then?
Yes, sir.
Okay, very cool. And how many tablets are we putting in here, Justin? One. And this one takes a little bit of time as well, or is this an automatic? Will we see something immediately?
It takes time.
It takes time too. So we drop it in, and we find out what's going to happen in just a little bit. The tension builds between dissolved oxygen, nitrates, and phosphates and pH. And now we go to the wonderful world of nitrates. I return to Caitlin and Diamond. What is a nitrate test and why do we care?
Nitrates are very important because they're required by all living organisms to build proteins. So we need them. Sorry. In low amounts, they can't support aquatic life, but too much is bad. Unpolluted is about 1 parts per million, and 10 parts per million is really unsafe for drinking water.
Okay, so if we're able to bring up the slide so everybody can see the color levels for the nitrate test, I'll ask for that slide to come up so everybody can see the color level of the nitrates test. And as Caitlin puts that in, Caitlin, ideally speaking then, we want less. We want to be down where it's the 5 parts per million. It's very, very light pink. That's what we're after?
Yes.
And is this a test, Diamond, we're going to see pretty quickly, or is this going to take some time for us to figure out too?
Yes, it should take 5 minutes.
Okay, so we're going to have the chance to see that as well. And again, you guys saw those colors. Light pink is better. Hot pink, Pepto-Bismol pink would not be a good thing. I guess that may be why you're taking Pepto-Bismol if the water has too much nitrates in it. Let's see as the test results come up, let's go to our student groups again to see what questions you have about testing for water quality or for any topics on conservation in the watershed today. St. Elizabeth, let's go to you first.
What would you do if you found that the water wasn't safe to drink?
Oh, if the water, what happens? What is the process if they find that water is not safe to drink somewhere? Is there a process in the state of Missouri? Does the governor, does the Department of Conservation declare a certain thing? How does that kind of process happen?
Well, that's regulated probably either by the local government or the Missouri Department of Natural Resources or the US EPA. And generally, if they find that there's a problem, that's going to get reported to one of those agencies, and then they're going to try to find the source of whatever the contaminant is and then deal with it however they need to in that way.
And that obviously happens at points in time. Kids maybe remember from the news whether it's an E. coli outbreak or it's a result of some sort of man-made pollution from a chemical factory or whatever. Those things happen. That's a great question, St. Elizabeth. Let's go back to Hinckley, Minnesota. Hinckley, another question from you.
Is the water stay the same in the creek or can it change?
Oh, the water is definitely going to change in the creek over time, right, Jamila? And that's going to be a fact. What kind of factors are going to affect water quality in like a creek environment?
In a creek environment, you're definitely going to have rain, stormwater runoff that will affect it. If there's erosion, if there's some fertilizer source or some other source that can cause pollution, that would definitely change the water.
Very good. And our students are waiting for their test results to happen. Caitlin, which one are we looking at right here that's in your hand?
This one in my hand is dissolved oxygen.
Is dissolved oxygen.
We've been inverting it for about 4 minutes now, and the tablets are almost dissolved, and then we need to wait 5 more minutes for the color to develop, even though you can see it's already started.
So you can see that the color is already starting to develop, but don't worry, the tension builds. We'll figure out what that color is in just a bit. St. Elizabeth, another question from you guys.
What are certain minerals that you look for in the water?
Naturally, water is going to have certain minerals in it already, right, Eric?
Correct.
Okay, so talk a little bit about the kinds of minerals we should always find in a water, and then the difference between finding them and like the level that would matter to us. Like, are we always going to find nitrates? Are we always going to find phosphates?
Trace amounts of nitrates and phosphates is good because both of those are used for living organisms. You don't want too many of them. That can promote too much growth, algal growth and things like that that would deplete, I think Justin had mentioned that, it would deplete some of the other oxygen levels and things like that.
And I'm assuming the minerals that are found in a specific water supply would depend to some extent just over the land that it's traveling over, right? I mean, obviously, minerals that are going through Montana where there's a great deal, we're being joined by Popper, Montana. They sent us some email questions. There's a lot of copper mines up in Montana. Obviously, water that's going through that kind of territory is going to have higher levels of maybe copper and zinc, those kinds of minerals, than other water that's going through another location. And so those kinds of things get monitored, though, right? I would assume to protect water quality for people's drinking water supplies, right?
Absolutely, absolutely.
And that's going to be true for your drinking water supplies, whether it's in St. Elizabeth or whether it's in Hinckley, Minnesota, or you're just in the St. Louis area. Your water department's constantly testing for water quality to make sure it's getting into your drinking waters of good quality. Let's go back to Hinckley, Minnesota. Another question from you?
What would happen if you were to consume too high or too low quality?
Well, what happens to if you consume too high or too low quality of water? Well, depending upon how much you drank and I guess how bad the water quality is, you're not going to feel good necessarily. You're going to, you know what I just mentioned, the color of pink, and I mentioned Pepto-Bismol. It might be that you'll actually have to use some Pepto-Bismol, I suppose, because water quality and what you're is definitely going to affect your insides. You're going to feel bubbles in your stomach. You might feel sick to your stomach, and if it's really bad quality of water, then obviously you might get sick. Ideally speaking, that won't happen if all things are working right for us. And I'm going to go back over here to Justin. Remind us, Justin, so the students know, you're looking for phosphate, right? And how close are we? Do we still have more time before anything's going to happen?
Yes, we got about a minute left.
So we've got about a minute left going there, and I'm going to move back up here to Mark and Ash. Mark and Ash, remind our students, Mark, what is it you guys were testing for?
We were testing the pH level.
pH level. And as you guys begin to look at it, I'm actually seeing some green color develop, right?
Yes. That's right.
And so that's a good thing.
Yes.
And if we compare that, and actually we can see that, feel free to hold that, guys, right by. And feel free to hold the test tube as close to the pH colors as you want. We're definitely in a light kind of bluish green. And if I get more purple, does that mean more acidic, just so we understand how to read the card right?
Yes.
Okay. Very good.
So
Thanks.
it's between 7 and 8, which is basically the good quality of water.
Okay. Between 7 and 8, that's a good quality of water.
Yeah.
Thanks very much, gentlemen. I know you need to record that data. And Caitlin, we've got some results perhaps here as well. What are we looking at?
We do. We are looking at dissolved oxygen.
Okay, so we bring the dissolved oxygen slide up. We can also show it on here. We're dealing with something that looks pretty mid-range.
It is. It's a little bit higher than 4 parts per million, which is what we want. We have a nifty little chart here where we can look at the temperature of the water, which is about 16. And we have in between 4 and 8 parts per million. So we've got about 61% saturation, which is good.
Oh, good. Very good. And notice the chart. We'll bring that chart up because Pete's camera's got it on there. And we'll bring up the chart that on Pete's camera that Caitlin has been recording on so you can see how that works. And so this was the temperature of the water. She looks at this chart and she then is able to determine the level of dissolved oxygen as well. Very good. Thanks very much. St. Elizabeth, I want to go back to you guys for another question. St. Elizabeth, another question from you.
What can you do if there's not enough dissolved oxygen in the water?
Are there things, that's an interesting question as we talk about this. Perry, I'll ask you to come join us over here. If you find that there's not enough of a certain element, like they asked specifically about dissolved oxygen, are there things that can be done, whether it's environmentally or chemically, to kind of balance it out and make it better?
If we're in like a pond situation or something where it's more still type of water, it could be the fact that we've got algae growth from some of the pollution that is depleting the oxygen, so then it's dealing with the things that are causing the algae growth and trying to take care of it that way. If it's more of a running water situation, a lot of times it's just a way to agitate the water a little bit more so you get a little more dissolved oxygen in that way. It could just be getting it over some rocks and things like that. For example, I worked on another project where water was coming into a pond from a parking area, and we did run it through an area, rough area, to try to agitate the water and get some more oxygen dissolved into it that way before it went into the pond itself.
Very good. Thanks for that question. Hinckley, Minnesota, another question from you, and then we're going to end up with our final test results here.
We live by a dam.
Oh, you have a dam. Is that what you're saying?
That's the dissolved oxygen.
Oh, does a dam or an operation of that nature potentially affect the levels that we're looking at here?
Depends. There's some situations where they draw water that goes through the dam.
Mm-hmm.
If it's towards the bottom of a lake, that water's probably not going to have very much oxygen in it. So when it releases out into the stream below the dam, that could be an instance where you're going to put in very oxygen poor water, and that could have a fish kill or something like that. Conversely, though, sometimes it's agitating it through the dam itself, and it's going over the dam or through it can add some oxygen to the whole situation as well. So it just kind of depends on each individual dam.
Very cool. Great question, Hinckley, Minnesota. Thanks very much. Kayla, I want to go back to you and Diamond. The second element that you guys were testing for was? Nitrate. And nitrate, as we look at it here, that's very light pink.
It is.
Which I'm assuming is a good thing.
It is a very good
We're
thing.
not Pepto-Bismol people, so that's good. So the likelihood of us having to use Pepto-Bismol is not very likely, and that's a fine thing. Very good. Thanks, ladies. And if I remember right, Mark and Justin, we still have to do our phosphate results, right? And I'll turn this around. I'll hold this while you hold the test tube near it. And I don't know if the world's going to be able to see just in terms of the camera light, but that's a very, very light blue, isn't it?
Yes.
And that's a good thing, I'm assuming.
Yes.
We want low level of phosphate, right?
Yes.
So I know you recorded that data. Excellent. And we see that it's a low level of phosphate. Thanks very much, Justin. I'll let you guys record that data. And our students are going to move to the whiteboard in a minute as they record some data so we're able to see a comparison of the kinds of water that we're getting as a result of these water quality tests from either a creek location or the pond location. So Justin and Caitlin and Diamond, I invite you to take your results and put them up on the whiteboard whenever it works for you. We've just got 3 minutes left. I want to go to some email questions and see what else we've been asked. Thanks very much for this email question about too much phosphate in the water specifically. Are there certain concerns about a certain kind of element? Like if there's too much phosphate in the water or too much nitrate or anyone you want to pick, are there certain things that might happen to people or to life, of plant life, that kind of thing? Jamila?
Too much nutrients in the water, that's when you usually see a lake that's kind of green. You get an algae bloom from too much nutrient. It blocks out sunlight. So your aquatic vegetation that's in the water won't survive. It has a lot of other impacts on the aquatic life that's in the water. So it can be a bad thing.
All right, very good. Thanks to everybody for those email questions. Don't forget, if you've got more questions, either from our interactive groups joining us via video conference, or for those of you watching on the web today or on television, you can email them to us at live@hectv.org, and we'll be happy to respond to them after the show. We can forward them to Jamila and to Perry, and we can let Eric have them as well, and our students can look. We're going to take a moment to switch our cameras, and we're going to move over to these whiteboards a little bit, because you're going to see the students recording data, both Caitlin and Diamond recording data that they found in the creek location. Mark and Ash have already recorded some data up at the creek location. You guys are going to be able to look at these kind of results in just a little bit. Hinckley and St. Elizabeth, we're really glad that you guys were able to join us for today's program. We really appreciate your participation. If you've got more questions, don't forget you can email them to us at live@hectv.org. There's a lot of resources available through the Missouri Department of Conservation and the Missouri Stream Team. We've included those resources and information we sent to the teachers involved today, but folks, you can also find them on the web. Don't forget to go to the web and look them up. And if you got a chance to come out here to the Little Creek Nature Area, tours are available. You can come out, you can enjoy it, and you can see what the students get to interact with here in Ferguson-Florissant School District as they work in the Little Creek Outdoor Education Area. Truly phenomenal facility and very unique in the area that gives our students in this particular school district a real chance to get their hands dirty, I guess, and their feet wet when they go into the ponds and creeks. So I want to be sure we say goodbye to Brianna and to Evan down there at the Little Creek, our Skype crew that came in, and we'll want to say goodbye to them, and really glad that we were able to see them. So Brianna and Evan, if you're able to hear me, feel free to wave your goodbye to everybody as well.
Of the water. And see you guys later.
And while Brianna and Evan do that, we'll come over here to the results that we're seeing in terms of comparison. And Eric, I'll invite you to join me up here and look at these very quickly. We're just comparing pond water to the creek water, and we can see that result. And as the world looks at these results, we're happy to say thanks to everybody for joining us here today from Little Creek Nature Area for our Going Green program. We look forward to connecting again.